Welcome wherever you are. Mr. David here. Let me take you through chemistry paper 2. Allow me take you through chemistry paper 2, July, August mocks. Question number 1. Define the following terms. Strong bases. What is a strong base? Amphoterism, solubility. So those are the terms. Then you using the equation below, identify the species that act as the base in the forward reaction. Give a reason. So you can see this is topic 1 in form 4, acid bases, which comes with the curves of solubility. So we want to define what a base is, but you should always you should know a base is a substance that dissociates completely in water to produce hydroxide ions. So the basic definition, then if it is an acid is a substance which dissociates completely in water to produce hydrogen ions, H positive hydrogen ions, and that is how you define. What is amphoterism? You should know amphoterism is the ability of a substance to act as both as an acid and a base. These substances which have the ability, they behave as an acid as well as they behave as a base. When they are put in a certain situation, a certain environment, they will behave as an acid. In another environment, they will behave as an acid. Examples, we have zinc oxide, we have aluminum oxide, then we have lead oxide, and they are hydroxides also. They are amphoteric. That is the definition. So an amphoterism is the ability of a substance to act as an acid and as well as a base. Solubility. What is solubility? Solubility is the maximum amount, is the maximum mass of a solute required to circulate 100 grams of a solvent at a particular temperature. At a given temperature, that one gives us solubility. So we have talked about that. You need to mention that maximum mass of a solute required to saturate, the keyword, saturate 100 grams of a solvent. The solvent could be water or another solvent at a particular temperature. Very important to mention. Using the equation below, identify the species that acts as a base and in the forward reaction. Now look at this equation. This is ammonia and this is water. This is ammonium ion and this is hydroxide ion. So what has happened? So remember the definitions of an acid. You need to know how to define an acid. We have around 3 definitions, but one of the basic acid, we know an acid is a substance which, that's how we define. But to produce hydrogen ions, that's very important. An acid is a substance which dissociates in water to produce hydrogen ions. So any substance which is going to produce hydrogen ions, then it is going to be an acid. So in this case, the water here is an acid. Why? Because it is the one which will provide, in the forward reaction, it is going to provide hydrogen ions. The hydrogen ions provided here will combine with ammonia gas to form ammonium, you see, to form ammonium ion. Therefore, in this case, ammonia will accept the proton from water. Remember, another definition for an acid is that an acid is a proton donor, while a base is a proton accept. So as the sub-acceptor, the substance which accepts a proton, that is the hydrogen ion, it is called a base. So in this case, ammonia is the base because it is going to accept hydrogen from the water. So ammonia is going to be the base. In this case, water is the acid in the forward reaction. When you come to the backward reaction, hydroxide is going to be, for this reaction to go back, hydroxide has to be added here So it has to provide, it has to remove the the hydrogen here in ammonium has to be removed so that they can form water again and come back. So in the reverse, ammonium ion is going to behave as an acid because it is going to provide the hydrogen ions that is going to combine with OH to form water. So in the reverse, hydroxide is the base, it is going to accept the hydrogen, and ammonia is going to provide the hydrogen, it is the donor. I think you have understood that concept. So ammonia accepts the proton from water to form ammonium ion. A solution of ammonia gas in water causes a greater diffraction of the ammeter than solution of ammonium gas, Explain this observation. Why do you think is that? But you know very well that ammonia in water, it dissociates completely to produce, it dissociates and ionizes to produce hydroxide ions. But methylbenzene, ammonia in methylbenzene does not dissociate. It only dissolves, but it does not dissociate to produce hydroxide ions. And we know the hydroxide ions are responsible for the diffraction. So if there is no hydroxide ions produced, then there is no diffraction. So in water, ammonia dissolves and ionizes to produce hydroxide ions. In methylbenzene, ammonia dissolves but it does not ionize to produce hydroxide ions. Very well. Write a well-balanced chemical equation for the reaction between sodium hydroxide, a solution, and zinc. So here we have two equations which takes place. I'm going to give you the common one. So we start with this common one. Zinc will react with sodium hydroxide to form sodium zingate. This one is called the sodium zingate plus water. That is the but I have a note here. In more concentrations, when you have more concentrated products here, we are going to form sodium hydroxozingate. But for this, if it is not highly concentrated, the simple equation is this one. So if you are asked to write that equation, just write this one, and this one forms a complex, but you can write also this one. It is the easier one. Explain how hard water is softened by ion exchanger method. Explain how hard water is being softened by ion exchange method. Remember, we have several methods of softening water, ion exchange being one of them. So the calcium ions in water and the magnesium ions in hard water are exchanged with the sodium ions in the column and precipitated out, and that is how that water becomes soft. The table below gives solubility of sodium chloride and sodium sulfate at 0 degrees and 40 degrees. When let me take this back. Yes, when an aqueous mixture containing 60 grams of sodium chloride and 70 grams of sodium sulfate in 100 grams of water at 80 is cooled to 0 degrees, some crystals were observed. Identify the crystals and determine the mass of the crystals. Very important. I want to help you to understand this table whenever you are given this table, and you will be able to solve it. Now look at this. This is solubility in grams. So solubility, it means, what is solubility? The maximum amount of a solute to saturate. So this is what it means, that sodium chloride, immediately it reaches, it has, we have 55 grams in 100 of water, immediately we have 55.1. It will form crystals. But from 1 to 3 mpaka 55, there is no, it will not form saturation. It will not become saturation at 0 degrees. So if you have more than 55 here, automatically it is going to form crystals. It will form crystals. So here sodium chloride containing 60 sodium chloride. So here we have been given 60, and sodium sulfate we have been given 7 at 0 degrees. So it was cooled from 80 to 0. So the final temperature is the most important. Ilifika 0 degrees, hapo ndio tunaangalia which salt will form. Do you think sodium sulfate will form crystals? No. Sodium chloride forms crystals at 55. That is when it becomes saturated. So if it becomes saturated at 55. So anything extra, it will form crystals. Anything extra, because we know a saturated solution. What is a saturated solution? A saturated solution is a solution in which no more solute can do what? Can dissolve at that same temperature. So if the temperature still remains 0, it will not dissolve anything more than 55, right? Therefore, anything more than 55 is going to remain as crystals. Similar, if it was cooled to 40 degrees, for example, if you are given that this one, the amount given here is 15, and the amount given here was 70. So it means when it is cooling from 80 to 40 degrees, at 40 degrees, sodium chloride required to form crystals or to become a saturated solution is 75. So 70 is less. So it cannot even, it does not even become saturated. At 70, it is not saturated. But this one here, 12, it requires 12 grams to become a saturated solution. Anything you add on top, anything you add here, it will form crystals. So if you are asked how much crystals were formed, so in this case, if at 40, we will form 3 grams of the crystals, that is 15 minus. So let's go direct and answer the question. I think I have exhausted this point. If you have not understood, that's all right. So identify the crystals. So sodium chloride will form the crystals. I have explained that. And what amount of crystals? It is 60 minus 55. So it will form 5 grams of the crystals. The method used to obtain crystals, it is called fractional distillation. Fractional distillation is the method used to obtain crystals. It is called fractional crystallization, not fractional distillation, sorry. It is fractional crystallization method. Number 2 question in our prediction is energy changes. We start by defining molar heat of combustion. You need to know how to define molar heat of combustion, molar heat of dissolution, molar heat of solution, molar heat of neutralization. Those are the things, the terms you need, or the definitions you must have, because you must be asked to define one as you continue. So molar heat of combustion, it is the enthalpy change that occurs when 1 mole of a substance completely burns in oxygen. That is what we call molar enthalpy of combustion. The enthalpy change that occurs when 1 mole of a substance burns completely in oxygen, and that is. Now, what about heat value? What is the heat value of a substance? This is the amount of heat energy that is given out when a unit mass of a fuel is completely burned in oxygen. That is the difference between heat value and that one. In an experiment to determine the heat of combustion of ethanol, a setup of apparatus was shown as shown in the below. Study the diagram and answer the questions that follow. So we have the diagram here. We have the thermometer, we have water beaker, We have the wing here, and we have the alcohol inside, which is ethanol. We are told the volume of water in the beaker is 100 centimeters cube. The final temperature reached 36, and the initial temperature was 22. Final mass of the lamp and the ethanol is 84.78, and the initial mass was 85.1. The density of water is 1 grams, and the specific heat capacity of water is 4.2. So calculate the number of moles of ethanol used in the experiment, number of moles of ethanol. So first you need to get the mass of ethanol itself. So we have the final content, we have the final, and we have the initial. You need to subtract to get the mass. Just subtract and get the so mass of ethanol is 85.10 minus this one, you get it is 0.2. So number of moles of ethanol will be mass over FM of ethanol. Ethanol you add, this is 12, so I can, ethanol is C2H5OH. So this is 24, this one is 24, plus hydrogen, plus hydrogen 5, plus oxygen 16 plus 1, so that is 17, and this one will give you 46. So that is the RFM, which gives you this number of moles of ethanol. Calculate the amount of heat energy of heat given out. Heat given out is what we call enthalpy change. The enthalpy change is given by the mass of the solution times specific heat capacity, we use capital C, then times temperature change. That is what we need to know. So we need to get the mass of the solution. The mass is 100 centimeters cube, because we have been given that the density of water is, so you chance to get it, you multiply 100 centimeters cube is exactly equal to 100 grams of water. So it is the same. Why? Because the density of water is 1, right? Yes. Now from there we have the mass of the solution, which is 100. Now we divide by 1,000 to make it in kilograms, because we have been given the mass here in kilojoules, kilograms. You can see here the specific heat capacity. Now we need to use to get our enthalpy change in kilojoules. So here you put over 100 to get over 1,000 to convert this one. That one gives you 5.88 kilojoules. But if you want to get in joules, you don't need to put over 100, over 1,000. You just, when you multiply mass times specific heat, mass in grams times specific heat capacity times temperature change, what you get is in joules. But when you change the mass into kilograms, you get in kilojoules, right? So what is the heat of combustion per mole? Heat of combustion per mole. So we will ask if this number of moles were able to produce this 1 kilojoules. We will ask 1 mole, because per mole 1 mole will produce what? So it is 1 times 5.88 divided by the number of moles, and it gives you 844.84. But you realize that I have given it in a negative form. Why did I give? Because in energy changes we have endothermic and exothermic reactions. In an exothermic reaction, there must be a negative. In an endothermic, you must indicate that it is endothermic. But look at this reaction. How will you know that it was exothermic? It is because the initial is 22 and the final is 36. So there was increase in temperature. So it means the reaction is exothermic. The reaction is exothermic, therefore you need to indicate here. If you don't indicate here as a negative, you won't get this mark. So be aware of that. If the temperature, initial temperature we were given is 22 and the final is 18, then you should know that is an endothermic reaction. Heat is absorbed and not released. If it is endothermic, it means heat is absorbed. Write a thermochemical equation. A thermochemical equation is one which contains the enthalpy change. Therefore, this is the enthalpy, the chemical equation. Up to here is called the chemical equation. But when we include the enthalpy change, it becomes a thermo. Thermo means heat. So we are showing that it produces this amount of heat. Explain how the molar heat of combustion for ethanol obtained above differ from the theoretical value. Yeah, it differs. It is always less because in this experiment, some heat energy is lost, some heat is lost to the environment, some heat is absorbed by the apparatus. So obviously, it will be lower than the theoretical value. So the molar enthalpy of combustion must be lower, is lower than the theoretical value because there are many reasons. One, it is the heat lost to the surroundings. Some heat is lost because if the beaker becomes hot, some heat is lost to the environment through convection or which other method or conduction. And then we have there is another thing, heat absorbed by apparatus. Some apparatus will absorb some heat. So at the end of the day, you will get a lower value. State one precaution that should be adhered to during carrying this one. One thing you should be is that be careful not to insert the thermometer until it reaches down the beaker. Because if it reaches down the beaker, it will absorb the heat directly from the source here. Because the beaker is very hot, unlike the water inside. Therefore, the thermometer should not touch the beaker down there. At the bottom, it should not touch. In this experiment, in this experiment, the assumption that links ethanol and water, yeah, the assumption is that we know very well that the amount of heat that is released by ethanol, it is exactly equal to the amount gained by the water. So that's how we get to measure the heat. It is because the heat released by the ethanol, it will be equal to the heat gained by the water in the beaker. Draw an energy level diagram for the combustion of ethanol. Now, first you need to remember that the reaction, the enthalpy change was exothermic, sorry. So if it is exothermic, then you should know how the energy level diagram looks like. In an exothermic reaction, the products have less energy. The products have less energy, so they have to the products must be below the reactants. So the reactants are higher and the products are lower in an exothermic reaction. And in an endothermic reaction is the reverse. In an endothermic reaction, the products are higher in energy than the reactants, and that's how we put. So if it was endothermic, you simply need to draw like this. So this will be the reactants and this one will be the products. In an exothermic, these are the product, the reactants, and these are the products. The products always have less energy in an exothermic reaction. The figure below represents a section of a periodic table. Study and answer the questions that follow. So we have the periodic table. Anytime you will be given this, because this in paper 2, you will never miss a question of the periodic table. Periodicity, that is topic 1 in form 2, topic 2 and the structure and the bonding. You will never miss such a kind of question. So that one, be sure 100%. So here, once you are given this, always start by naming this one, giving the number so that you can know which element is in which. So this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We only do the first 20. So once you are done like that, now you will be able to see that number 15, number J is silicon, number 13 is aluminium, number 12 is not given, number 11B is sodium. So that is the key word. You need to label it like that to see which element is placed where. Explain why the atomic radius of element H is smaller than its ionic. H is chlorine. Why is the ionic radius, why is the atomic radius of element that is chlorine smaller than the atomic radius? Remember, chlorine reacts by gaining an electron. Chlorine reacts by gaining an electron. So what happens once it gains an electron? The chloride of chlorine has 17 protons. The number of protons in the nuclear, because remember, protons are found in the nuclear, electrons are found in the energy levels. So the protons and the proton and the neutrons are found in the nucleus, while the electrons are found in the energy levels. So the chloride ion has 17 protons in the nucleus, which attracts 8 electrons. The electrons, because when chlorine reacts, it reacts by gaining 1 electron. So the chloride now contains 17 protons in the nucleus, attracting 18 electrons. You see that? What does that do? In the energy level, what does that do? The effective pull, because now the electrons in the outermost energy level is supposed to be pulled by the nucleus, by the forces of the nucleus. But since now the electrons are more than the protons in the nucleus, you find that the energy required to pull them is lower, is more, is less. So the effective pull of electrons in the energy level by the positive nucleus reduces, while the size of the particle increases. There is what we call electron repulsion. I don't know whether you understand. So actually what it happens is that the atomic radius of chlorine, that is H, is smaller than its ionic radius due to electron repulsion. That one is called electron repulsion between the existing electrons and the incoming electron. When you say like that, you have explained everything and you are done. When element H is dissolved in water and a blue litmus paper dipped, the color of the litmus paper changes from blue to red, then white. So remember, this is chlorine. Chlorine is a bridging agent. So immediately the chlorine is dissolved in water, it forms chlorine water. Once it forms this chlorine water, and chlorine water is acidic, it is acidic. Now immediately the chloric 1 acid inside the chlorine water breaches the litmus paper from red to colorless, which they call here white. So it becomes because of the bridging action of chlorine. So a solution, you can also accept a solution with the bridging properties is also another answer that is acceptable. Explain what is likely to be observed when element H is bubbled through solution of element I. Element I is iodine. Iodine is below chlorine. So chlorine is more reactive than iodine. That is true. because for halogens, reactivity decreases down the group. Reactivity decreases. That's why fluorine is the most reactive, followed by chlorine, iodine for us. So what happens is that if chlorine is bubbled through a solution containing iodine, of course iodine is going to be displaced. It is because it is less reactive. So the solution will turn dark brown. Dark brown is iodine, which is going to be displaced. So the solution will turn or change to dark brown because element H displaces the ions of element I. In other words, because this is a displacement reaction, chlorine is more reactive than iodine, so it displaces the iodine from the solution. This is simply an explanation. You don't need to write everything, but once you write a solution turns this color because of displacement, then that one is understood. Compare the atomic radius of element G and element J. So we go back to check where element G is. Element G is aluminum, element J is silicon. You can see that. So the question is, between aluminum and silicon, which one has a smaller atomic radius? Remember, across period 3, the atomic and ionic radius decreases across the period. The atomic and ionic radius decreases. Why does that happen? Remember, across the period, you see the number of, this is 13 protons, 14 protons, 15. So across the period, the number of protons increases from 11 to 18. Number of protons are increasing. So at least there is a proton, a proton which is increased. There is a proton added to the nucleus. So this one increases the effective force of attraction at the nucleus. The effective force of attraction is it is very high in 18 than it is in B. You see that? Meaning the pooling of outermost energy levels in 18 is very high because the number of protons are 8. When you look at J has got 1 extra proton in the nucleus, while this one has 13. This one will have more extra. Therefore, it will have more effective force of attraction in the nucleus, which will be pulling electrons from the outermost energy level towards the center. I don't know whether you are getting that, but that is the point. So J, which is silicon, has a small atomic radius. I have said across the period, the atomic radius decreases than G because it has more protons and hence stronger nuclear force of attraction that pulls the energy levels, the electrons in the energy, that pulls the electrons, in the energy level, levels closer to the nucleus, Now that one, the pulling makes the atom across the period to become smaller as you move to argon. Use the dots and the cross diagram to show the bonding between B and H. So you go back and check which one is B and which one is H. Then now you use bonding knowledge and see which bond I, B and H. That is sodium and chlorine. So sodium and chlorine, this is a metal and this is an non-metal. So we expect them to undergo ionic bonding. They will have what we call ionic bonding. Sorry. So we were told to use, so it is an ionic bond of sodium chloride, that's B and H. But you are supposed to use the dots. So use the dot and the cross to show the bonding. So that one you simply write sodium. Then you write the first energy level and then the second energy level after losing the 1 electron. So you can use dots here, dots. This one has got So this one has already lost. This is now an ion, or that is, this is sodium ion. This one is sodium ion. It has lost one, so it becomes positive. Then the ion, the electron lost from sodium is taken by chlorine. So this is chlorine ion, and it is going to be negative. So we will use the X here, 2, here 2, here we can have 2 here, then here 2 and 1 dot from the electron obtained from sodium, and that is how it is going to combine. G chloride has an expected bond type and structure. State the type of bond and the structure. G chloride. G is aluminum. Aluminum chloride is not an ionic compound. I need to know that it is unexpected actually. We don't expect that aluminum chloride should not be an ionic compound. So aluminum chloride is a covalent dative bonding which takes place. Then the structure is molecular. So why is it very different? It is very different from sodium chloride. Sodium chloride, because sodium chloride, magnesium chloride, they are in group 3. The chlorides in period 3. The chlorides in period 3 should be having the same characteristics. But this one is totally different from the rest. When the other chlorides are neutral, this one is acidic. You need to know that. When these other chlorides like sodium chloride form ionic structures, giant ionic structures, this one is making a molecular structure. So those are the differences that are taking place here. A piece of blue litmus paper is placed in a solution B chloride and solution G chloride. That is correct. So B chloride, this is sodium chloride, and this is aluminum chloride. Aluminum chloride. There's nothing here. So aluminum chloride. Explain what would have observed. Of course, here the blue litmus paper will remain blue in sodium chloride because sodium chloride is an ionic compound. But in aluminum chloride, the blue litmus paper will change to red because actually aluminum chloride hydrolyzes in water to form acidic solution. Very unique compound. Aluminum chloride is very unique, and it behaves totally different from the other chlorides. There is now a table here of time. It is the rate of reaction of copper, 2.5 grams of copper to sulfate. So volume of gas produced, hydrogen gas, and the time taken. Why were the following not used in the reaction? Nitric 5 acid. Why was here we are using the volume of hydrogen using hydrochloric acid? So copper 2 sulfate crystals were added to zinc granules and 100 of dilute hydrochloric acid. The question is, why was dilute hydrogen chloride used and not nitric acid? Why do we use a nitric acid? You need to remember that nitric acid is an oxidizer. Therefore, the hydrogen which is going to be produced will be oxidized immediately to form water. So we don't use this one because it will oxidize hydrogen produced. Iron powder. We do not use iron powder because it produces hydrogen sulfide, which is very poisonous. Now draw a graph or plot a graph of volume against time. Volume of, and it is a curve. Remember, I have said severally that if it was to calculate the rate against, any graph of rate against volume or time is going to be a straight line which passes through the center, which passes through the origin. But if it is volume against time, that one is a curve. You need to understand that. So here we will have a curve. This is the graph. This graph A in 25 degrees. That is what you are supposed to draw. It will be like that. Use the graph to calculate the rate of reaction at time is equal to 25. So time is equal to 25. You come to your graph here. This is 20, therefore 25 is here. So you draw a dotted line up there, where you meet the curve. Now here at the curve, you draw a tangent at this point. You draw a tangent. Now you will get this point and this point. Now get those points and calculate the rate by change in y, because rate is equal to change in y over change in x. That one gives you change in volume over change in time will give you the rate. So you need to get the tangent. So for you to use this one, we need to show this dotted and then you draw a tangent there. If you don't do that, you did not use a graph. So a tangent must be drawn on the curve. Its gradient determined, and once you get the gradient, your answer is the correct one. Explain why the volume of gas produced does not exceed 122 centimeters cube. 122. So the volume of it will not exceed 122. Of course, it will not exceed. The reason is that by that time, the hydrogen gas, the hydrochloric acid would have been exhausted. As the reaction proceeds, the hydrochloric acid is being used up. When the volume is 122, all the acid has been used up. So we will not have an excess gas extra. How does the catalyst used? Now on the same, sketch the graph y on the same grid to show the result if the experiment is repeated at 10 degrees. Remember, one of the factors which increases the rate of reaction, one of them is temperature. When you increase temperature, the rate of reaction increases. When you decrease temperature, the rate of reaction decreases. Another one is concentration. Another one is the catalyst. Now, use of a catalyst. But now, you see temperature has been decreased so where do you expect the curve to be? So the curve has to be below the one for 25. So this is how the curve should look, because it should be below the one or at the 25 degrees, because the temperature here is higher. It means the reaction for this curve is very high, but for this one it should be below, right? Correct. How does the catalyst used in copper 2 sulfate used? How does the catalyst used, that is the copper 2 sulfate, speed up the reaction? Of course, it provides it lowers the activation energy. Or another thing it does, it provides a large surface area for the effective collision of the reacting particles, increasing the rate of reaction. State Regitalis principle. This is now equilibrium. When a change in the condition is applied to a system in equilibrium, the system moves so as to oppose the change. Yes, when a system is at equilibrium, you remove something or you add something on it, you will change the condition and it has to move to oppose the change. What is the effect on the position of equilibrium when dilute HCl is added to the closed system of the following reaction? In this reaction, I have explained earlier that this one is going to, this water, this is an acid in this case. This one is a base. So HCl contains hydrogen ion. So once you add hydrogen here, you are adding hydrogen here. So it will favor the forward reaction. So the position, equilibrium, will shift to the right because you are adding more. Now you are changing the concentration of hydrogen ions, and therefore the equilibrium will shift to the right. Give the UPAC names of the following organic compounds, the UPAC name. So we want to name this. So first try to count to get the longest carbon chain. So let's start from here. So this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Let's start now down here. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. So you can see the longest carbon chain here is 5, penta. It is a penta something. So it is a pentane, because you can see here it is an alkane. So that is, it is very important for you to count the longest carbon chain, because if you did not do that, you will not get correct. So the correct way of labeling it, we start counting here at this place here. 1, this is carbon number 2, carbon number 3, carbon number 4, and carbon number 5. So now to give the name, in carbon number 2 we have the methyl group, and carbon number 3 we have the methyl group, and there are 2 of them. Therefore we will give it as a di. So this one is 2 kwa carbon number 2, 3 dimethyl pentane. Look at this one. This is the triple bond. That is an alkyne. That's so simple. You count from the left or the right. It's okay. 1, 2. So this one is called 1, 2. That is butyl but2-ine. But2-ine, because it is but2-ine. It is a triple bond. It is an alkyne. Now we have an organic flow chart here. We have the soda lime, we have the propane. Now propane is one which will guide us. So propane is undergoing hydrogenation, platinum, you can see here the catalyst. So where is it coming from? If it is coming from propene. So you can see that it's coming from propane. And the propane is manufactured from soda lime. And now you can see this one, how alkanes are prepared in the lab. So you should know. Now, like this is propane, then the solution is, it is one C should be sodium. Sodium, 1 carbon ahead of propane, that is proputanoate. So it should be butanoate. It is, so C is sodium butanoate. So when propane is formed, there is another product that is formed, which is sodium carbonate. Okay. So A is propene, B is sodium carbonate, sodium butanoate, then propyl hydrogen sulfate. When you add propene in the presence of sulfuric acid, you form propyl hydrogen sulfate. State how a substance A could be an A and a propane could be distinguished. How would you distinguish propene and propane? Of course, propene are saturated while propane is unsaturated. Right? So propene will decolorize bromine water, while propane will not. Another thing is that you can use the potassium acidified potassium dichromate or manganate 7. If you use acidified potassium manganate 7, which is purple, propene will decolorize, will change the color of acidified potassium manganate from purple to colorless, while propane will not. So that is another way you can distinguish. Give the components of soda lime in step 1. Step 1. The components of soda lime. Soda lime is made up of calcium oxide and sodium hydroxide. What is the industrial application of a process that converts substance A to propane, that is hydrogenation. You can see this is hydrogenation. How did you know that it is? You can see hydrogen is being added here in the presence of the platinum catalyst. Therefore, it is hydrogenation, and the advantage of the hydrogenation is used in the manufacture of margarine, and also you can say it is used for making or hardening oils to form fats. In the laboratory, preparation of propene using propanol, broken porcelain, and sodium hydroxide solutions are used. State the use of broken porcelain and sodium hydroxide solution. So this one is used. Remember, this is the reaction where we use concentrated sulfuric acid reacting with propanol. We have a picker containing sodium hydrogen carbonate. Why do we use sodium hydrogen carbonate in that experiment? Remember, in this experiment, sulfur 4 oxide and carbon 4 oxide is produced. So broken porcelain is to prevent pumping that could lead to flask cracking, and sodium hydroxide is used to bring out or to remove carbon 4 oxide and sulfur 4 oxide produced during the experiment. Draw a fully labeled diagram of apparatus you could use to electrolyze an electrolytic in the aqueous. So this one is a general one. You need to show us where we have the petri here, and in the petri this is the positive. The longer one is positive, the shorter one is negative. So you label here, this is the cathode and this is the anode. In electrolysis, the anode is the one that is positive and the cathode is negative. But when it is in electrolytic cells, it is the other way around. In electrolytic cells, the cathode is positive and the anode is negative. So be aware of that. So this is the setup you need to do, and then you label here the electrolyte. This is the electrolyte. Explain why crystals of sodium chloride are non-conductors of electricity, but when melted, they conduct electricity. Yes, sodium chloride, whether sodium bromide, in solid form, they do not conduct electricity. The reason is simple. In solid form, the ions are fixed. They cannot move. They are immobile. But in aqueous state, the ions are mobile and responsible for electric conductivity. In melt form, the ions are mobile, hence conduct electricity. State what happens to melted lead to iodide when an electric current is passed through it. Remember what happens? If it is lead iodide, then the positively charged ions of lead will migrate and be attracted towards the negative, which is the cathode, while the iodine, which is negatively charged, will be attracted and move towards the anode, which is positively charged. When they reach there, some will lose electrons, others will gain electrons to form their respective products. So lead ions will migrate to the cathode, while iodine ions will migrate to the anode. Write the equation at the cathode. Red ions will gain 2 electrons to form the lead ion. So here we will see the lead beads, the brown beads of lead. The brown beads of lead. Is it the gray? It is the gray beads. We will see the gray beads of lead at the cathode. Why is it necessary to carry out this experiment in the fume chamber? Iodine will be formed. And once iodine is formed, you should be aware that iodine is very poisonous. What is a binary electrolyte? This is an electrolyte which contains only 2 cations. One is negative and another, two ions, that is, a negative and one positive. So that is what we call an electrolytic binary. Bi means two. Bi means two. So it is an electrolyte which contains only one type of cation and one type of an ion. Like now lead iodide is a binary. Sodium chloride is a binary. But when we talk about HCl, not HCl but sulfuric acid is not a binary, because sulfuric contains hydrogen ions. In water it contains hydroxide ions, and it has sulfate. Yes, it has sulfate ions, so it is not a binary. Sulfuric acid cannot be a binary. It's not a binary because it has more than one anion. It has more than one anion in water. You see that? Yes. Give the application of electrolysis in the chemical manufacture of industry. Manufacture of hydrogen, manufacture of chlorine. Remember, we use electrolysis to manufacture chlorine. In the process, sodium chloride is manufactured. Extraction of metals. Metal extraction. We extract very reactive metals during using electrolysis. We also purify metals using electrolysis. Jewelry and so during electroplating, we make those copper or whatever to be very beautiful. So electroplating makes jewelry very beautiful. This is the diagram to present industrial manufacture of hydrochloric acid. Use it to answer the questions that follow. Dry hydrogen, water, grass beads, hydrochloric acid, storage chamber. Name the main source of hydrogen in this process. Main source of hydrogen, it is either from the natural gases or from the cracking of alkanes. The reaction between chlorine and hydrogen can be very explosive. Yes. How can this be avoided? You pass hydrogen through a jet and burn in excess chlorine. What is the role of grass beads in the absorption chamber? The role of the grass beads in the absorption chamber is to increase the surface area for absorption of hydrogen chloride gas in water. Explain why rubber, the storage chamber for hydrochloric acid, is made up of steel reacting with rubber. Of course, steel will react with the acid. Acid will react with steel to form, and therefore rubber is used. The acid obtained is 35% pure. Calculate the molarity of the acid at the 25. The density of the acid is 1.6. So here first we have been given the density. You simply need to get if 1 gram 1.08 grams is 1 centimeters cube. Molarity is the volume in 1,000. Molarity is in 1,000. So we will ask 1,000 centimeters cube will contain what? So that one will be 0.80 grams. So that is the grams in 1,000. After that, the purity. So you can calculate the purity. You can get the molarity 29.1 and then subtract that is the impure when it is even in impure, but the purity one should be 10 points. So instead of doing this way, just get the mass of the pure. So pure will contain 35/100, the purity times 1080. So that one will give us 378 grams per liter. So that is the pure. Now molarity is equal to mass, which must be in grams per liter, you divide by the RFM. So our mass is 378, you divide by the RFM of HCl, because it was HCl, that is 36.5, and that one will give you 10.36 molar directly. Thank you. Share the video.